Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Greetings to my supervisor, Hazran Husain, and my panelists. I am here to propose and present my final year project proposal with the title of Effect of Inlet Size and Location on Aircon System using Energy Recovery Ventilator. A summary for this project is to simulate aircon system using energy recovery ventilator. The current server room is using common split aircon system and cause high energy usage due to the high temperature of the room. So energy recovery ventilator or ERV will be added for pre-cool purpose of the server room. This project is to see the difference of the temperature when we added the ERV unit into the server room. Also, the effect of inlet size and location of the ERV will be analyzed using the CFD simulation. As an introduction, what is ERV? ERV stands for Energy Recovery Ventilator. It's a system designed to be connected to the ducts that are part of the hatchback systems. By two fans, ERV draws clean and fresh air into a home or space and remove the stale air. How ERV works? An ERV works by capturing the air that exhausted from the room and using that air to create the energy needed to ventilate the room. In warm weather, ERV removes humidity and moisture from fresh air entering the room. From that, the air coming inside the room becomes cool. For the literature review, I've been searching journals and research papers that are related to my topics. There are a few research papers. The first one is from J. Liu and B. Wang. They state that energy recovery ventilator is commonly used in commercial, industrial, and apartment homes in China. Its power-saving quality depends on the environmental conditions of the outdoor environments, the exchanges enthalpy efficiency, and so on. To enhance the quality, more efficient enthalpy pyramids and more efficient fans need to be researched. The appropriate period of operation according to local climate should also be carefully considered. Next is study from A. Himerson and U. Paulson. They state that the ERV is an exchanger of heat and humidity. The two air flowing streams are fresh outdoor air, which is feed, and stale room exhaust air, which is sweep. The ERV uses the energy difference of the two air streams and no outdoor energy is supplied to the unit. The third research paper is from A. Bernardi and his friend. They state that the ERV area is installed inside the tempered space of the building, normally in the mechanical basement area near the outer ports. Other possible locations include a wardrobe, a laundry room, a workshop, or even in the garage. Commonly, designers are hanging it from the ceilings. There are generally different shapes and size of ventilation inlet for building vents. While most codes and Standards rarely perceive the relationship between the energy consumption and the indoor environment. This will result to the undue ventilation in the building's ventilation designs, which does not let the efficient use of energy. The problem that I faced while doing this project is I didn't get the dimension of the server room and also the server rack, and also the exact location of the server rack in the server room. Because of the pandemic disease that occurs in our country, I didn't manage to go to the UITM and take all the dimensions. Other than that, I also didn't have the simulation software that needs to be used to do the analyzing, as my laptop that I currently use has low specification. So the solution for this problem, I studied the simulation software in the YouTube to get the rough idea to make this project success. Okay, here is the two objectives in my project, which is firstly to simulate the aircon system in server room using the energy recovery ventilator. The second one is to analyze the effect of inlet size and location of the energy recovery ventilator. For the scope project, I'm decided to use two different inlet size, which is firstly 300mm times 300mm and also 500mm times 500mm for the inlet size. The second is I'm using the two different location of the inlet. The CAD model also, I'm using the CATIA software to draw the CAD model. For the analysis, I'm using ANSYS software to simulate the CAD model. For the limitation, the dimension of the room is not obtained, and also the size of the room also did not obtain. For methodology, I have three stages of method. Firstly is researching, which is I'm searching the journals or research paper that related to my topics. The second is designing the CAD modeling. The third is analysis using the CFD simulation software. Okay, for the first method, I'm do the research by collecting data from journals and research paper. For research, mostly the journals and research paper, I'm using the Science Direct website mostly, and the other is the Mendeley and ResearchGate. All the data and information were related to my topics. The data and the information that collected can be used to get an idea to achieve the objective of this project. For the design CAD model, before I'm into the CAD model software, I'm do the rough drawing or sketch on A4 papers to decide the dimension of the server room, the rack, and the inlet size and the locations. There are 4 cases with different inlet size and location of the inlet and outlet ventilator for this project. There are 2 different locations of inlet and outlet of the ventilation. The first location is both inlet and outlet ventilation is on top of the room on the ceiling. The second location is the inlet vents is on the wall, while the outlet vent is on top of the ceiling. The 3D model of the server room will be analyzed by using the ANSYS Fluent 2020 CFD simulation to observe the temperature distribution, the air velocity distribution of the room. The use of CFD requires a governing equation, which is the conservation of mass, the momentum equation, and the energy conservation. And then to analyze the model, we need to applying the boundary condition like inlet and outlet boundary condition, and also wall boundary condition. After the analysis, or after done the simulation, the result will be studied, and any failure in the result, we will do the retest, and or the CAD model will be redesigned until the better result are achieved. For this project, I expected that the CFD simulation software can simulate, and I can analyze the effect of the inlet size and location of the ARV. Also, the temperature of the server room will be identified, whether the temperature will drop after added the ARV. Okay, that's all for me. I hope that I had clearly explained my proposal to you. If any questions or comment, you can directly contact through the WhatsApp number or email. Thank you.